In the next videos, we're going to learn how to use the equations of kinematics. We have three basic equations. One describes the position of an object at a moment in time. The other describes the velocity of an object at a moment in time. And the third describes the acceleration of an object with respect to time. Let's begin by discussing the first equation, which is written in black. This equation describes the position of an object at a given moment in time. This equation is for one-dimensional motion, meaning that it could be applied to the x-axis, the y-axis, the z-axis, or any other line. And in this case, we've written it for the y-axis. In other words, this equation describes the y position of some object at a moment in time. The left-hand side of the equation describes the actual position at that moment in time, and the right-hand side of the equation has three parameters. y0 represents the initial location or position of our object, that is the position at time t equals 0. v0 is the initial velocity of our object at time t equals 0, and it's multiplied by t, which is the time that we're measuring for. And last, we have 1/2 times at squared, where a is the acceleration acting on an object, and that's multiplied by the time squared. Let's look at an example. Suppose we have the following initial conditions. y0 is +1, meaning the initial position is 1 meter above the 0 point, or where y equals 0. v0 is +10, meaning that the initial velocity is 10 meters per second upwards. And the acceleration is -10. And we've written g for the acceleration because in most kinematics equations, we only include gravity as our force acting on an object. You'll often see the number for gravity as 9.8, which is technically more accurate, but we want to work with more comfortable numbers, and it's easier to manipulate 10 than 9.8. Also, keep in mind the signs of each parameter. We have a minus sign for gravity telling us that gravity acts downwards, or points downwards, whereas the plus signs for the velocity and position tell us that it's upwards above our 0 point. Now, keep in mind that we may not be given these initial conditions in terms of their numbers directly, but we may be given them in terms of a word problem. For example, we may be told that a body 1 meter above the ground is thrown upwards with an initial velocity of 10 meters per second. In this case, we should be able to translate our word problem into the given parameters. For example, being told that the body is 1 meter above the ground tells us that y0 is +1, and the initial velocity is 10 meters per second upwards tells us that the initial velocity is +10. And again, because we're dealing with an object thrown in the air, the only force we consider is gravity, which as we said is -10. In our example, our equation would look like this. y parentheses t equals 1 plus 10 times t minus 5 times t squared, where the 5 comes from 1/2 times -10. We can plug in different values of t and see how the position changes. Our initial time is usually taken to be t equals 0. If we write t equals 0 and plug that into our equation, then we have 1 plus 10 times 0 minus 5 times 0 squared, which is just 1. And indeed, the initial position of our object is 1 meter above our reference point. If we let the time run, then we see how the position changes. For example, as the time increases, then the y position goes from 1 to 2 to 3 to 4, and eventually goes back down. For example, when t equals 3.91, then the y position of our object would be -36.43. That is 36.43 meters below the 0 point. Let's set the time back equal to 0 and let it run again. And let's pause it, and we see that when t equals 0.2, then the position of our object is at 2.8. Now let's look at another example, and let's pay attention to the motion of the object. We see that as the time increases, then the ball goes up in the air, and then briefly stops and begins falling back down. This gives us a better idea of what the motion of the object actually is like. So let's go over what we did today. We said we have three basic equations of kinematics. One for the position of an object at a moment in time, the other for the velocity of an object at a moment in time, and the third for the acceleration of an object at a moment in time. In this video, we looked at the equation describing the location of an object in time. We plugged in the initial conditions for an object and saw how its position changed as the time increased. Looking at the equations and the animation, we should have a good idea of how bodies move under gravity. That's going to do it for this video. I hope you're now more comfortable with using the equation for position of an object with respect to time. In the next video, we'll look at the velocity of an object with respect to time. So I'll see you then.